Alright, in this particular video what we're going to be doing is comparing quadratic functions. This is going to be pretty easy. All we have to do is compare f of x, which is right here, to g of x, which is right here. Alright, so we're just going to compare these. Right now it says which function has the greater y-intercept. Well, that's in standard form, f of x. The answer would be 2. That's the y-intercept for f of x. And it looks like the y-intercept for g of x would also be at a 2. Yeah, that's where g of x actually hits the y-axis as well. So we have a y-intercept at 0, 2, and then we have a y-intercept right there at 2. So which function has a greater y-intercept? Well, they have the same. So we just have to search for the answer that says they have the same y-intercept. So that's what we'll do. Scroll down. F and G share the same y-intercept. That's our answer. There you go. Alright, next problem. It says, how many roots do the functions have in common? So we have to identify what the roots are. So we're going to identify the roots of, let's see, g of x. We have a root right here at a negative 2. And we have a root right here at a 4. So what does that mean? That means we have a solution set at a negative 2 and a 4. Those are our solutions, or our zeros. Now, we got to find the roots for f of x. So what I'm going to do is I'm going to factor it. Rewrite the equation. 2x squared minus 4x minus 16. I'm going to end up dividing everything by 2 to make it easier to factor. So divide everything by 2. Makes it easier to factor. So we're left with x squared minus 2x minus 8. And we're going to be looking for two numbers that add up together to equal negative 2, but those exact same two numbers multiply together to equal negative 8. So what are those two numbers? Well, negative 4 and positive 2. Because negative 4 and positive 2 multiply together to equal negative 8, and they add together to equal negative 2. So they multiply together equal negative 8, add together equal negative 2. So we're going to put x minus 4, and we're going to put x plus 2. And that's all equal to f of x. Alright, so what number would you plug in to this equation to make it equal to 0? What number minus 4 equals 0? 4. What number plus 2 equals 0? Negative 2. So our solution set's going to be negative 2, comma 4. Interesting. They share the same zeros. Maybe they're not the same equation, but they do share the same zeros. So we say they share the same roots, which is the same as zeros, or solutions, or x-intercepts. Now we're going to go ahead and do a couple more of these just to show you how easy it is. Comparing quadratic functions. Here we go. Loading up. Alright. Now, do these functions have the same concavity? Now, concavity means whether something opens up or opens down. Well, g of x, you can clearly see, opens up. We call it concave up. The other one, f of x, it doesn't show you the graph, but there is a rule about parabolas being in standard form. If the a value is positive, it opens up. If the a value is negative, it opens down. That's called concave down, when it opens down. Alright, so g of x definitely opens up. F of x also opens up, so they do have the same concavity. They both open up. Our a value is 1, which is a positive number. And I'm going to write down if a is greater than 0, ax squared plus bx plus c. If the a value right here is greater than 0, which means it's positive, it opens up. But if the a value is less than 0, which means it's negative, it opens down. And that's why we're going to say they both are concave up. There we go. They're both concave up. Click it. Alright. Now this one says, which function has a greater minimum? Well, f of x is written in vertex form, and the vertex will be at 5 and at 2. And g of x, there's the vertex right there at negative 2, comma 3. So our vertex right there for g of x is at negative 2, comma 3. And f of x, our vertex is at a 5 and a 2, because that's in vertex form. So which has the greater? Well, g of x is greater than f of x. They're both minimums, the lowest points in their graphs. But clearly g of x has a greater minimum than f of x. So we're going to say g has a greater minimum than f. Alright, and last but not least says which function has a greater y-intercept? Well, f of x has a y-intercept of 12, and g of x has a y-intercept of 1, so you can clearly see that f of x is greater than g of x. And I think that's going to be the end of our video. Hopefully you guys can compare your quadratic functions.